Understanding error-checking memory. Two primary types of error-checking memory that have been used in systems over the years. The following sections introduce you to these two types of error-checking memory. Be sure to become familiar with them for the A+ exams. Parity versus non-parity. Parity memory is a type of error-checking memory, which is memory that verifies the information stored in memory is what is actually read from memory at a later time. Non-parity memory, comparatively, is memory that does not perform any kind of error checking to ensure that the data written to memory is what is actually read when it is retrieved. Parity non-parity. Here's how parity memory works. The two types of parity memory are odd and even. Both parity methods function the same way, but differ in the sense of whether they look for an odd number of bits or an even number of bits. This discussion uses odd parity as the example. With parity memory, for every byte, 8 bits, of data written to memory, there is an additional 9th bit. Parity. So 1, 2, 3, 4, 5, 6, 7, 8. That's our byte. So with every byte, when it's with parity, it puts one more bit. So there's 9 bits total. So with parity memory, for every byte of data written to memory, there is an additional 9th bit. That's the parity bit. Parity bit. When storing information to memory, the number of the enabled bits set to 1, written to memory, are added up. When storing information to memory, the number of the enabled bits written to memory are added up. So every bit can either be turned on or off. So not all of these will always be 1s. Some of them will be 0s if they're turned off. So in this example, all 8 are on. And so when it's parity, we're going to add everything up. So all 8 plus the 1 parity bit means 9. So that's 9 total. With odd parity, 9. 9 is odd. With odd parity, if an even number of data bits are enabled, the parity bit is set to 1. Enabled. So that there is an odd number of enabled bits in total written to memory. If the result of all the enabled data bits is odd, the parity bit is set to 0, so that the odd number of enabled bits is retained. So if this is odd memory, then this works, because it's 9. It's already 9. It's already odd. So there's odd parity, there's even parity. Odd and even. Now, if this was even parity, then we would set this parity bit to 0, so that the total would just be 8, because 8 is even. So after the parity bit has been set, the byte of data and the parity bit are written to memory. Even parity works the same way. Even parity works the same way, except that it looks for an even number of enabled bits. If the number of enabled bits is odd, the parity bit is enabled. So let's say this byte was made up of a 1, a 0, a 1, a 0, a 1, a 0, and a 1 and a 1. So then we add all of the ones, everything that's turned on, because 0 means turned off. So we add all the ones, everything turned on. That's 1, 2, 3, 4, 5. So that's 5. And then we have our parity bit, right? Okay. So if we're having odd parity, then we'll leave this parity bit off because we already have an odd number. That's 5. And then so it would just send this byte. It would store the byte, the odd parity, and it would have your little 0 parity bit stored with it, with odd parity. If it was even parity, then this little parity bit would be on. So it'd be a 1. So it would make the total 6, right? Because 5, that's your byte of information, plus your parity bit is on to make it 6. Because that is even. So that's even parity. And so the parity, it'll store the 5, and then it'll store it with this 1, this parity bit, if it's even. So even parity, odd parity. That's what parity memory is. It's a, what does the book call it? It's a error checking memory. Now, if it's non-parity, it doesn't do any of that. Let's see, what does the book say? Parity versus non-parity. Non-parity memory is memory that does not perform any kind of error checking. So there you go. Non-parity doesn't do any of that. So parity, even and odd, non-parity.